Hello, in this math video, I will do a GED math video regarding simplifying rational expression. So rational expression basically means a fraction. So if you see anything in fraction form, we're dealing with a rational expression. So just like the other video, I'm going to go over some rules before we do any of these problems. So go ahead and get out your notebooks. We're going to write some rules down. So these ones are kind of quite a few. So rule one, or first rule, when it says simplify rational expression, you must factor as much as possible to cancel as much as possible. So when they say simplify, you're not going to solve for s, right? You're just going to factor and cancel as much as you can. Okay. So yeah, when it says simplify rational expression, you must factor as much as possible to cancel as much as possible. Okay, second one, it says when subtracting polynomials, first find common denominator, then factor to cancel as much as possible. Yeah, when subtracting polynomials, first find common denominator, then factor to cancel as much as possible. Okay, the last one. Uh, to, so to find the excluded values of a rational expression, factor as much as possible, then set the denominator zero and solve for x. So yeah, they will in this they will ask for an exclusion. It's basically your vertical asymptote. So to find the vertical asymptote or the exclusion of a polynomial, I mean a rational function, you factor as much as possible. If something cancels, fine, cancel it. If something doesn't, fine. Then you set the denominator to zero and then solve for x or whatever your letter is. So yeah, to find the excluded values of a rational expression, factor as much as possible, set the denominator to 0, and solve for the variable. Okay, uh, got it. So go ahead and write that down if you need to pause the video. Okay, I am going to do question one now. Okay, so question one says, which of the following is a simplified form of the rational expression? So they want you to simplify this rational expression. So basically you got to factor, cancel, and then, yeah. So if you look at the top here, let me rewrite this. We have, on the numerator, we have x squared minus 4x minus 45. And then at the bottom, you have x squared minus 16x plus 63. So you need to know your factor though. So let's factor the numerator. How do you factor x squared minus 4x minus 4? It's just simple factoring, right? The a value is 1, so you can just try to do this. You don't have to do bottoms up. So how do you do this is you're going to put an x here and an x there. So you could, yeah, x squared and then blank space, blank space. Now this is the tricky part. Can you come up with two numbers that are multiplied -45? When added those two numbers, you get -4. Yes, I believe it would be -9 and +5. So check it. What's -9 times +5? -45. What is -9 plus 5? -4. Okay, so you're going to put -9 here and a +5 there. Now do the bottom. So write out your two parentheses. And then I need an x here and an x there, and then one space, space. So can you come up with two numbers that multiply 63 and when added gives you -16? Yes, it would be -7 and -9. So what's -9? -7 and -9? +63. What's -7 plus -9? -16. You could switch the order around. You put the -9 here and the -7 there. It doesn't matter, right? As long as the signs are correct. This has to be -7. This has to be negative. Okay, so you factor this. Now the fun part. Cancel. Do you see anything that's the same? That's exactly the same top and bottom? Yes. I see the x minus 9 is the same on the bottom and x minus 9. So they cancel. So you're left with x plus 5 on the top and then x minus 7 on the bottom. Okay. So letter P. Okay. That wasn't too bad because the factoring is called simple factoring, right? When the a value is 1. It gets trickier when the a value is not 1 or if there's more than 3 terms, right? But if you need to know all the rules of factoring, go ahead and watch for the supplementary video, and then it should be called factoring. Okay, it'll go over all the factoring rules you can think of. Question 2. Which of the following expression is the simplified form of the given expression? So we have 2y minus 1 over y squared minus 2y minus 15 minus y squared minus 2y minus 15. Okay, so we said that in the notes that if you're adding or subtracting polynomials, must find the common denominator. Okay? So how do you find the common denominator of a rational expression? Just look at the bottom denominator. So on this side, we have y squared minus 2y minus 15. And then on this side, we have y squared minus 2y minus 15. The good news is they're exactly the same. Sometimes it won't be that nice where it's exactly the same in the bottom, but since they're exactly the same, That is your common denominator. So our common denominator is y squared minus 2y minus 15, right? Okay, so on the bottom, just the bottom is always your LC, so it's going to be y squared minus 2y minus 15. Now on the top, so okay, usually you multiply top and bottom. Sometimes the common denominators you have to multiply top and bottom by something, but because the bottom is exactly the same, we don't have to worry about that. The only thing we have to worry about is this minus. So you could think of this minus as invisible -1, and then foil that minus out. So that's going to be -y, and negative times negative is +4, and then this stays the same. And then collect like terms. So you have a 2y and a -1y. That is positive y. And then you have 4 and -1, which is +3. And then what you want to do is simplify it by factoring. So can we factor this rational? Yes. The y plus 3, that is, you can't do nothing more with that. That is what it is. Now, the bottom, y squared minus 2y minus 15, there's three terms. There's a power of 2, the a value is 1. That looks like simple factoring, right? So write out two parentheses. Put a y here and a y there, and then blank space, and then blank space. So can you come up with two numbers that are multiplied -15 and when added gives you -2? Yes, it would be 5 and 3, and I'll use -5 and +3. So -5 times +3 is -15. -5 plus 3 is -2. Okay. So now the fun part, do you see anything that's cancels or anything that's the same top and bottom? Yes, I see a y plus 3 on the top and a y plus 3 on the bottom, so they cancel. So now you're left with 1 on the top and then y minus 5 on the bottom. So it looks like A, right? 1 over y minus 5. Yes, it's definitely A. Question 3, which of the following is or are the excluded values of the given expression? So when they say excluded value of a rational expression, so see how this is a fraction. You basically want to factor this as much as possible, and then if something cancels, that's fine, cancel it. Then you want to set the bottom to 0 and solve for your x, right? So let's start with factoring. So on the top, x minus 2 cannot be factored, so it's just x minus 2. On the bottom, it factors out as x times x blank space blank space. We're going to do simple factoring. So can you come up with two numbers and multiply 4 and when added gives you 5? Yes, 4 and 1 is 4 times 1 is 4. And then 4 plus 1 is 5. Okay, so do you see anything that cancels? No. Okay, so what you have to do next is you have to set the bottom to 0 and solve for x. So our bottom is parentheses x plus 4, parentheses x plus 1. Okay, go ahead and set that to 0 and solve for x. So some people can automatically see when you solve for x, your x values are going to be -4 and x is going to be -1. Some people can see that automatically. But what you're really doing is setting each parenthesis to 0 and solving for x. For example, you're setting x plus 4 to 0, and then x plus 1 to 0, right? And then you're going to subtract 4 for both sides. So you get x equals -4. The same thing here, you're going to subtract 1 from both sides. You get x equals -1. Okay, so you're excluded. So what this means is you can x can never be -4 and x can never equal to -1, right? If you do plug that in the rational, if you plug it back in here, it'll make the bottom zero and it will be undefined. So that's why it's so it's going to be -4 and -1. Okay, perfect. We got it all right. Okay, so that was like a small taste of factoring and solving for x, right? Um, like I said before, if you need a refresher to find common denominator or factor all the factoring rules, just check out the supplementary videos of this course. Okay, I'm going to stop here.